to undo than it is to move towards. So we're going to use this idea that u prime is equal to du over dx, like that is a true statement, that's just notation stuff. We're going to connect that though and use the idea that dx is equal to du over u prime. Main idea, like you want to identify the correct u, and then when you find u prime and you do that substitution, you hope that things cancel out. We looked at indefinite integrals yesterday where all of our answers were like the antiderivative plus c. Today I wanted to look at examples with the definite integral. And the reason why I want to focus on the definite integral is because this is going to be one of the things that College Board, and thus I will also have to be a little bit picky about when it comes to the notation. And I'll go through kind of the things we have to be very picky with. I am going to show you two ways to do the indefinite integral. I definitely have my preferred way, but College Board is going to expect you to know how to do both ways and how to set them up both ways. For me, the easiest way to do an indefinite integral is just to ignore the numbers on the integral sign, mainly so you don't mess up with any of the notation mistakes that they would take points off for. And so like if I see this problem, this is the integral from 0 to 2. There's the integrand of dx. I am just going to pretend, even to the point of rewriting it, that this is just the integral of the cubed root of 8 minus 2x squared with respect to dx. I'll get into why we want to just pretend that those numbers aren't there in a second, but now we can go ahead and just do it like we were doing yesterday. So we want to identify the u. Again, u is often what we see on the inside, so I'm going to let u be this 8 minus 2x squared. U prime then is going to be negative 4x. I can already look at that problem and see that that's going to work because those x's are going to cancel out. Show as much work as you need to with u sub, so I have x on the cube root of u, and then dx is du over the u prime. Good to go because those x's are going to cancel out, and I can go ahead and rewrite that and find the antiderivative. That over negative 4 means I can go ahead and bring a negative 1/4 outside my integral sign. And I'm going to go ahead and rewrite the u as u to the 1/3 du. That shows us kind of why u substitution is important. We've taken a complicated integral and turned it to something that was easy and simple to do. So that negative 1/4 is a coefficient, so I'm going to carry it down. And then go ahead and find the antiderivative. U to the 1/3, add 1 to the exponent, divide by that new exponent. There's my plus c, and then of course my u is 8 minus 2x squared. Can leave my answer like that. I'm going to go ahead and simplify it as negative 3 over 16, 8 minus 2x squared to the 4/3 plus c. Now we're technically not done. So like this was a definite integral. We know that the answer to a definite integral is a number because that number is representing the net area under the curve. We'll finish that in a second. I do want to go in first about the notation. So one thing that the AP exam is going to be picky about is when we say things like dx, that does have a lot of meaning behind it. We'll get into a whole lot of other meaning like when we start doing like word problems and all that. For us right now, dx means in terms of x, which means everything before that dx has to be something in terms of x, which in this case it is. Like all of that is just a bunch of x's. Even more importantly, that dx tells you that this 0 and that 2 are x values when you're integrating. Like eventually we might be something that says like dy, so then those would be like y variables instead of x variables. So the issue that you want to be careful with is as soon as you write du, that means everything has to be in terms of u. So on the AP exam, and I will treat it the same way on my assessments, an answer that would automatically lose you points, you would probably still get the correct answer. But if you wrote the integral and had like the negative 1/4 of u to the 1/3 du, and if you were to kind of carry over the original numbers of 0 and 2, that would automatically lose you points. And that doesn't look wrong, but what's making it wrong is you just said, hey, this is an integral in terms of u, but we have x values on our integral. It's kind of like if you were to measure like one thing in centimeters and the next thing in inches. Like you just don't want to mix units of measurement like that. They call it in calculus officially like a linkage error, a notation error, but it's just something that you want to avoid. So the easiest way to avoid it, just from my experience, is just to, hey, pretend you have an indefinite integral, find the indefinite integral, so find the antiderivative, and then go back and plug in top minus the bottom once you got rid of all the u's. So then to finish out this problem, there is my antiderivative. Then I'm going to finish it out by evaluating it. So I have the antiderivative. I'm just going to rewrite again. Now that all of those are x's, now I can go ahead and plug in the top number minus the bottom number. So plugging in the 2, negative 3/16. That's going to be 8 minus 2 times 4, 8 minus 8, 0. That's pretty convenient. Minus plugging in the bottom. Plugging in 0, so it's going to be 8 to the 4/3. And I'll be lazy and leave my answer like that, because you don't have to simplify your answer. Wouldn't lose points if you did this, because yes, 0 into our x values, and everything is in terms of x. That's just like one thing to be careful with. More of a notation thing than anything else, but that is how we're going to evaluate definite integrals. That's going to be one way we evaluate definite integrals with u sub. Any questions so far? Yeah.
So could you plug the lower bound and upper bound into your u?
Yes, and I'll show that in a second.
Okay.
You're being smart and thinking ahead. Yes.
Isn't it the top one minus?
I did. I just simplified it as I was plugging in. That 0 came from 8 minus 2 times 2 squared.
Okay, sorry.
It just happened. That's kind of weird how it looks like that. But yeah, that's where that came from. So go ahead for me. I think I added a little bit too many slides here. I talked about notation. Yeah. So that's what I'm going to call option A. So there is another way where we can do that problem where you convert everything in terms of u, which I'm going to do in a second. But go ahead and try this one for me. Again, just making sure you show like the proper notation, or mainly don't show improper notation. When I say option A, that's going to be where you're going to pretend it's an indefinite integral first. Then evaluate. So maybe a chance to do it that way. Once you do it that way and then we go over it, I'm going to show you a second way, which Evan kind of alluded to, where we can kind of rewrite our limits of integration.
Mr. Brown,
Yeah.
on like a test or a quiz, would you make this do it one way or the other?
So when we learn the second way, I'll show you how I can force you to do it that way. It's often like a multiple choice question. It'll be something like, what's the setup, or like what's an equivalent integral? So like you're not actually solving it, but you have to understand like the middle step to get there, yeah. And it's usually on the AP exam every year is a multiple choice question. That is usually one question I can predict. Don't need to simplify your answer, but you practice just evaluating the trig with the unit circle. And again, you can't show as little or as much work as you need to with u substitution. For this one, I'm definitely not going to show a lot of work. It's pretty easy for me to know that when I do du over u prime, like that's where that 1/2 is coming from. Again, show the steps if you need to kind of see what that coefficient is going to be. But I think that was a pretty easy one to kind of show not as many steps for. So again, if I'm doing this definite integral to make sure I don't show any errors in notation, I'm going to pretend that this is an indefinite one. Find the antiderivative, then plug in the top number minus the bottom number. U is equal to 2x, so I'm going to let u prime be 2. Not only let u prime be 2, u prime is 2. And so then that becomes the sine of u, And I do have du over u prime. Du over 2 just means a 1/2 is on the outside. Finding my antiderivative. So 1/2 is a coefficient coming down. The antiderivative of sine is negative cosine. I'll go ahead and plug u back in. Now that this is back in terms of x's, I can go ahead and put those x values next to it. Again, I never want to mix up x values with u values. And then we can just go ahead and evaluate this. And we know when we evaluate it, we're going to plug in the top number minus the bottom number. So negative 1/2 the cosine of 2 times pi over 2 minus the negative 1/2 cosine of 2 times pi over 6. Simplifying this, pretty easy. I think that becomes the cosine of pi. That's over at 180. Cosine of pi is negative 1. Negative 1/2 times negative 1 would be positive 1/2. Double negative makes that a positive, and we have a 1/2. Cosine of pi over 3 is going to be another 1/2. Leave your answer like that, but easy enough to say 1/2 plus 1/4. So that is option A, where we treat it like an indefinite integral, find the antiderivative. Once we get rid of the u's, I can put those x values back next to it, and then just plug it like we know how to, like plug in the top number minus plugging in the bottom number. Questions on that problem? All right, so then the other one that we have is option B. Again, I typically don't do it this way unless, like for some problems I might see that it's an easier way. Do need to know how to do it and understand it, but option B is when you're going to put everything in terms of u. Not just like the integrand, but everything in terms of u. I'm going to work it out kind of next to it so you can kind of see the similarities and differences. I'm going to rewrite the integral right here just so I have we're straight down the page. When you're going to put everything in terms of u, that means the integrand and those numbers on the integral side, those limits of integration. It starts off the same way. Like we're going to have u is equal to 2x. U prime would be equal to 2. So doing my u substitution, I have the integral that becomes the sine of u, du over u prime. Looks identical, but we're going to go ahead and translate these numbers we have, so the pi over 6 and the pi over 2. Right now those are x values. We're going to make them u values. And how do we make them u values? Well, this is an equation. We did say u is equal to 2x. That gives you a relationship between all the x's and u's. So if u is equal to 2x, then u of pi over 2, that's like function notation, would be equal to 2 times pi over 2, which is just pi. So instead of putting pi over 2 on the top, I'm going to put pi on the top of my integral sign. And then I'm going to do the same thing for the lower one, u of pi over 6, 2 times that pi over 6 is equal to pi over 3. So instead of pi over 6, I'm going to put pi over 3. Sometimes when you do that, these problems, like those numbers on the integral sign, will no longer be in order. Sometimes like the smaller ones ends up on top. But you have to remember that these are no longer like x-axis numbers. These are like numbers in terms of this like u function that you have. How they often test this on the AP exam, like they will give you the original question, and then there'll be like choices A, B, C, or D. Which of the following integrals is equivalent to the given one? And like that would be the answer choice. Like you wouldn't actually solve it, but you would try to get it down to that last step we have right now. Finishing this one out though, we will see that it ends up becoming the same answer. It's like find the antiderivative 1/2 of the negative cosine of u. Do want to be careful though. Notice I left my antiderivative in terms of u, since those number values are u values, not x values. So I don't want to put 2x back in for u. And then literally just plug in the top minus the bottom And now it looks almost identical to the other way of doing it. We'll even see we get that same 1/2 plus 1/4. So 2 ways of doing the problem. I will never tell you which way you need to do it, but you do need to kind of understand both ways, especially with this idea of translating your limits on your integration sign to no longer be x values, but to be u values. That's kind of like a big idea that we'll be looking at. Questions are things that I can clarify about that problem. All right, one more problem to do, and then that's going to be it for today's notes. And that's going to be my what if slide. So one reason that I like math is that it does like always follows rules, like pretty predictable. We do know, however, in math there's always like some problems that aren't really exceptions to a rule, but just like taking the rule and approaching it in a little bit different way. This is one of those problems. It's going to be one where we have to do u substitution, but u sub unfortunately just doesn't work like we want it to. Let's make sure it's clear why this one will be u sub. We have a product. We know that we can't just find the antiderivative of each factor of that product. I can't like distribute this x across to get rid of it because of that square root sign. So like we can't do anything with that answer. So let's go ahead and start doing it with u substitution. I'm going to go ahead and let u be 1 minus x. That's what's on the inside. U prime, the derivative of 1 minus x is just going to be -1. And now I can go ahead and do my u substitution. So I'm going to have the integral of x, and then that's going to become the square root of u. And then dx is du over u prime. What's the issue with that integral?
Nothing cancels out.
Nothing canceled out. Particularly, that x did not cancel out, and we know we don't want that x in the problem. We can get rid of it. So this is kind of where like that new kind of is like, well, what happens when things don't cancel out? We can actually go back to this equation again like we did kind of to change the limits of integration. But in math, we know that if we write an equation, any arrangement of that equation is also true. Like just think back to like when you were solving systems by substitution in algebra 1, like you could solve it for x, solve it for y, doesn't matter which one you choose. So if I say that u is equal to 1 minus x, then I can just do some quick algebra, add x to both sides, and then subtract u, and I get x would be equal to 1 minus u. And so now I can do like a second substitution, and that will help me get rid of the x. So this is going to become the integral. What is x? 1 minus u on the square root of u du. Du over -1. I'm just going to move that negative on the outside so I don't have to deal with it right now. Looking at this one, still have to kind of keep thinking about it. Like we can't integrate it as written. We do have a product. But now at least everything is in terms of u. So like we know that we can eventually hopefully do it. And we can, it's actually pretty easy. Like now we can go ahead and get rid of that parentheses by distributing that square root of u across. If it helps you see it a little bit better of where we're kind of distributing across, so I have 1 minus u, u to the 1/2 du. When you distribute across, same base, just make sure you add the exponents. And so then basically we'll no longer have a product, and we can just integrate each term separately. So I have the integral, going to not forget about that negative sign. 1 times u to the 1/2 is u to the 1/2 minus u to the first times u to the 1/2 will be u to the 3/2 du. Now we can just kind of use it like what we did at the very beginning, power rule, and then kind of simplify. So I have negative on the outside. And I'm going to put some parentheses because I know that negative is going to have to distribute across my integral sign. U to the 1/2. 1/2 plus 1 is 3/2. Divide by the new exponent. Minus. Need a little bit more space. U to the 3/2 plus 1 is 5/2. Divide by that new exponent. Don't forget my plus c and what u is equal to. Fine if you leave your answer like that. I'm going to distribute that negative just so I have a few less parentheses to deal with. So negative 2/3, 1 minus x to the 3/2 plus 2/5, 1 minus x to the 5/2 plus c. But either of those answers would be correct. I do think a problem like that really shows the power of U substitution. Like looking at that final answer, I don't think really anyone would look at the original problem and think that the derivative of your answer is x times the square root of 1 minus x. You could check your answer, of course. Like you can always take the derivative of your answer. To simplify it and check it, you would have to end up doing some things like that fancy factoring and then canceling out some like terms. But it does end up being the derivative of x times 1 minus x. Questions on that problem? So again, that will only happen when all the x's don't cancel. Do you want to say like one disclaimer? Sometimes if all of your x's don't cancel, you just chose the wrong u. But if it ends up being just like an x left over, then there is a high chance that you just need to get rid of it by doing like a secondary substitution. So that's where I'm going to go ahead and finish notes. I do have a warm-up that we will do tomorrow that just has 2 questions on it. But for the remainder of class today, you can go ahead and continue working on homework number 4. Again, for homework 4, I'm just requiring you to do the multiples of 4, still skip 32. If after checking your answers, or if you have to rely on the answer key a lot, then go ahead and just do all of the evens just for the practice. I will say there's nothing like else intensive that I have to do to review, or to teach, excuse me. Like the rest of the unit is literally just going to be review and practice to make sure that you are literally experts on U substitution before we move on to the test, and then of course unit 6. If you finish homework 4 early, then you can definitely begin homework 5. If your homework 5 is coming in blank, I know it's coming in blank for some of my classes, then just right click on the icon, if I can spell, and select refresh printout. So really for the rest of this week, we will be reviewing. Tomorrow we'll have the warm up and I will take questions on the homework that we can go over in class. Again, if you finish homework 4, then I do suggest moving on to homework 5. I wrote homework 5 kind of looking at common missed questions from both my AB and BC quizzes over the past few years. I know it's weird to have kind of like favorite worksheets, but I really like some of the questions on homework 5 because it really kind of forces you to make sure you understand how to choose U, especially for like a lot of problems that look similar. And I also just have a lot of just like commonly missed questions on that homework. So again, many of you are probably almost done with homework 4 if you've been kind of on task. Feel free to start homework 5, and that way you can just kind of focus on reviewing the briefcase binder and quiz corrections next week. So y'all can go ahead and get started. If you have questions at home, just kind of raise that little yellow hand, and I'll make sure I get your questions answered. And then if you're here in person, then just obviously ask a question. Yeah.
I want to make sure I get this number correctly. No, this one is not.
Yeah, 12 you don't need to use, so. So you just found the antiderivative there, and then the bottom of the box.
And then, looks like, so, I'd probably put this one on.
Number 8, that one would be use of using the inside, derivative of negative 8x, so all that cancels.
I think I forgot to take the.
You just, yeah, you haven't found the antiderivative yet.
Okay, so that
You just haven't
would
finished it.
be the
You
one.
do the 4/3 and then multiply by 5. Yeah, yeah. Got any questions? Good. Good. Do you have questions? Yes. So, so an area below the x-axis is negative when you're moving forwards. So if you're moving backwards, area below would be considered positive. Yeah. Yes.
So just to make sure that this
Plus C,
number
yeah.
plus C.
Yes.
And then for this one, it already has a U.
So, you do like V substitution or
Oh,
just pay a variable.
okay.
Yes.
Can I change it back to S?
You can do like
Okay.
that. Another question? Yeah, we're just have a fire drill, so it's at 310. But we get some back, it's another email, so they'll probably watch the parking lot. How many do you have to speak out? That's what you're doing. Well, people look out for people that are on the outside.
Say what?
Well, people look out to see when people start running to their cars.
So like round two, be able to pick out the guys. What doesn't it just go straight to the class once it's in there?
They still have to wait till it's dismissed, so we'll just wait. Oh.
So now I'm tempted in moving my class closer to like her classroom there.
Should we or should we not bring her back, guys?
We'll be coming back, so. This will be past the straight line.
Attention teaching students, as well as this time, we ask that you please report to your primary evaluation site. Please report to your primary evaluation site and wait for further instructions.
flat. It's not that noticeable, but if you like really look at it, it's kind of like flat.
Sometimes like.
It's just like,
Do you know where the,